Have you been struggling to get your 3D printed feeding rings to float in your aquarium? It turns out there's a science behind it. Buoyancy. Today we're diving into why some rings float, why others sink, and how you can use this knowledge to design the perfect feeder ring. Here I have 3 feeder rings I designed and printed out of PLA plastic using my FDM 3D printer. At first glance, they might look similar, but when I tested them in my tank, 2 floated and 1 sank. Let's figure out why. This is ring 1. It's 90mm in outer diameter and 70mm in inner diameter. It has a 1mm thick wall and a hollow space inside that's 8mm in diameter. It weighs 9 grams. Because it has a lot of hollow space relative to its material, it displaces enough water to create a strong buoyant force, allowing it to float. Ring 2 is slightly different. It also has a 90mm outer diameter and 70mm inner diameter, but its walls are 2mm thick and the hollow space is only 6mm in diameter. It weighs 16 grams, but it still floats because the hollow space provides enough air to offset the material's density. Now here's ring 3. With thicker 3mm walls and a smaller 4mm hollow space, it weighs 21 grams. Despite being the same size as the other rings, it doesn't have enough hollow space to displace enough water and create the necessary buoyant force. Its higher density causes it to sink. This all comes down to buoyancy, which is explained by Archimedes' principle. An object floats if the weight of the water it displaces is equal to or greater than its own weight. In other words, if you want your rings to float, you need to make sure their overall density, including the hollow space, is less than the water's density. Let's talk density. The density of fresh water at 75 degrees is about, and this is Fahrenheit, is about 0.997 grams per cubic centimeter. Anything denser than that will sink. The PLA plastic I used for these rings has a density of 1.25 grams per cubic centimeter, which is denser than water. So how do we get it to float? By adding enough hollow space filled with air to lower the overall average density. Here's the problem with ring 3. Its thicker walls and smaller hollow space means its average density is greater than the water. As a result, it sinks. But rings 1 and 2 have larger hollow spaces that reduce their average density, allowing them to displace more water and float easily. So what's the takeaway? If you want your 3D printed feeder rings to float, focus on increasing the hollow space while keeping the material as minimal as possible. This will keep their average density below the density of the water. And there you have it, the science behind why some rings float while others sink. By understanding buoyancy, density, and water displacement, you can design feeding rings that work perfectly for your aquarium. Or if you guess pretty good, you can get that to work most of the time too. If you found this video helpful, don't forget to like and comment and subscribe. Let me know in the comments if you had success with 3D printed aquarium accessories or if there's a project you'd like me to try next. Thanks for watching and I'll see you in the next video.